Right, now let's go through the basics first, right? Now you know these days we are as individuals we are using databases if wherever we go. Even now we are using databases. Here we are using databases. So whatever I am talking here or the recording, it recorded in somewhere in the server, isn't it? So, and then we are using lots of wearable devices like handheld devices, phones, and then we are using a lot of other intelligent tools. Nowadays, actually, other tools like televisions, refrigerators, even there are a lot of intelligent devices uh, generate a lot of data that we need to actually manipulate to make it available for related parties to make appropriate decisions. So databases are everywhere, right? Whatever we are said and doing, databases are there. So the main thing is how we going to design it. What are the basic principles involved in it? Is what we need to actually study. So there are basic definitions. Let's start with the small definitions regarding databases. So database we can define as a organized collection of logically related data. Now this definition looks very easy or very simple, but there are lots of stuff actually integrated into that definition, right? Logically related data. So what do you mean by logically related data means? Okay, so that is what we need to actually. So when the semester progresses, you will learn what do you mean by this definition. Okay, so collection of logically related data. So they actually think about data, right? So what do you mean by the data? That is a main important definition we need to actually understand. What do you mean by the data? Now, data, how are you going to actually define the data? Right, right. So anything, now, for example, we can, in your enrollment, we have the enrollment data, right? So when you enroll in the university, you record all your information, your interest, your contact details, every bits and pieces can be regarded as a data. Okay, so data is kind of is a stored representation of meaningful object. So if you think about a student, yourself is an object when it comes to the university's point of view, right? So you have enrolled in subjects, right? So the enrollment details and other objects, right? And there are some events as well, right? So not only the objects, but there are some events that companies or enterprises are interested to record the necessary data regarding events. For example, sales. Sales is a kind of an event, right? So order can be an event as well, right? So these events, objects, which is interested to the organizations, they need to capture and store all these meaningful data related to these objects and events. So when it comes to the data, we can actually divide or classify the data that we interested into two types, right? Some data are structured type of data, right? For example, sometimes when you buy a product, or even when you think about your enrollment, that is a structured kind of, because we can actually specify or give a meaningful structure for what kind of data we are going to record or analyze in our databases, right? So usually the structured data consists of numbers, texts, or dates, etc., etc., right? So if you buy some product online, so you place an order, you need to record your contact details, order details, right? And then the delivery details. So we can actually place a kind of a structure. We know exactly how order looks like, what kind of information we need to capture, right? So basically all these order details and your details consist of numbers, text, and dates, right? Etc. etc. So we have a structured type of data. But nowadays, there are some other, because there are so many other devices we are using. right? Intelligent devices, and we are using social media technologies, GPS technologies, and sometimes we use sort of maps and videos. We are sharing lots of different multimedias through social media platforms. So there are so many other type of data that generated in so many other contexts as well, right? Images, videos, documents, etc. So these sort of data we can't actually pre-specify how the structure looks like, right? But we need to still integrate these information into our daily databases or data that we are going to use, right? So we call these images, videos, and all these tweets and all these multimedia kind of data as unstructured, because we are not in a able to pre-specify how the structure looks like. For example, when you're sending an email or when you're sharing some social media kind of message via your Facebook platform, we can't actually specify exactly what kind of information, how the information is going to structure. So these are called the unstructured data. So we have nowadays technologies in place that we can actually capture the unstructured data and analyze in a meaningful way that companies can make some sort of decisions, right? So there are basically two types of data, right? Structured data, unstructured data. So both those data are actually very important for the organization perspective. Now, data itself will not actually meaningful, right? It will not give a kind of any meaningful uh, information, kind of ideas for the organization. So what we need to do is we need to process this data in order to enhance the knowledge of the person that they are trying to use it. That is called the information, right? For example, if you think about your enrollment, right? So your name, your date of birth, your other contact details. That is actually meaningless if you just sits in some place. But if you put that your contact details, your details with the subject details and your future, degrees that you like to enroll in, now that actually give you a kind of a meaningful information for the decision makers that can make a kind of enhance their knowledge to make appropriate decision, right? That is something that we need to understand when we designing the database, right? For example, so that means if you put a kind of a data into a particular context, you can enhance the knowledge. That is where the information come into play, right? So you can see here the class roster. We organize pieces of data in a meaningful way, right? And then that can be actually further do further analysis, like for example we can summarize all these class rosters, and then we can analyze like how many subjects we are delivering, so how many students are enrolled in each subjects, the trends on these subjects. And then of course the management can decide whether do we need to hire new tutors or new lecturers for these subjects. So what are the new subjects we are going to offer, because there is a trend in some other areas, etc., etc. So all these stuff actually require some kind of database technologies, right? um, but at the same time we need to think about, because when you think about these data, we need to actually think about the metadata as well. So what we mean by the metadata is these database or data that when you give put into a specific context, we need to explain what kind of data used in that particular context, how the data is going to structure, right? What type of data is involved in that particular context, etc., etc., etc. So metadata is a data that describe the properties and the context of the user's data in a particular way, right? So that is also important when you're designing a kind of a databases, right? So database itself is not a kind of an individual thing. So there are lots of bits and pieces involved in that, including the metadata. And then of course we need some kind of a program that we can use to manage all these stuff, right? That is what you mean by database management system. So we call it as DBMS, right? It's a software that used to create, maintain, and provide a kind of a control access to the user database, because we don't want to give everybody to access all these data and information and the metadata, because we need to control it in a certain way, right? So we can use this so-called database management system. So in this semester, we are using Oracle as our database management platform. So we are not going to actually use the Oracle to give the control access to other users, but we use as a users, right? Users in the database. Okay. Right, so this is an example of a metadata, as I mentioned before. I told the metadata is something which describes the data. So we can say the metadata is a data about the data, right? For example, you can see here. So if you use this metadata, so we need to describe what kind of data involved in this case, the class roster. So class roster include these sort of data types, right? For example, we have what is the course that the student enrolled in, the section, semester, name of the student, etc., etc. And then also we need to describe what kind of data is that. It is a arithmetic data, or is it, sorry, it's alphanumeric data, or is it integer, decimal, etc., etc. And also we have to say that it is a context we are using it, and then the source this data is coming from. So this is also very important when you're designing a database. Designing the metadata is another important thing, right? But we are not going to actually learn how to design the metadata, because it's another course that we are going to deliver in the higher education. But this semester we are not going to touch into this particular place. Okay. All right. So one of the key things that we need to understand how these database technologies have been developed. So prior to the development of the databases, the early days in 1970s, in early 1970s, actually most of the data has stored in the individual files, right? For example, if you think about the Excel spreadsheet, it's an individual file, right? So we can put all these data in Excel spreadsheet and individually manage, right? So early days also the same thing happened, right? So we create these data files, so individual files, and these individual files are managed by the separate programs, right? So this is what we mean by the file processing systems. So when the business become more complicated and then more integrated and more kind of globally expanded, so people or the companies then realize that it is really difficult to live with these individual file processing systems, because there are so many limitations, right? There are so many shortcomings and the limitations. So they develop this database approach to overcome this file processing system, right? But still, in some companies, we still make kind of have this isolated systems. I know that there are some other companies we are working, they still using this legacy isolated system, where there is a very less integration between different systems. So this is what we need to do. So these are the disadvantages of the traditional systems. So if you maintain separate files, or separate files to keep the separate information, this is called file processing system. So what are the disadvantages of file processing? For example, now think about this example. Imagine a company, right? So organization, we have different divisions like accounting department, order department, payroll department, etc., etc. So if we develop different databases for individual departments, so you can see in this case we have certain programs for the department and certain programs for the accounting department, and there are certain programs for the payroll department, right? And they individually maintain their own systems, like own files, right? For example, order department, they maintain the customer files, inventory files, and whatever the back orders the customers request us, although we keep that in a separate file. Same time, the accounting department, they have a separate files as well. So one of the main disadvantage of this system is because the programs and the data are dependent to each other, right? Because when you think about all these files, right? So remember that I have told you, whenever you create these files or the data, we need to create the metadata as well. We need to describe what is the context and what type of data, and the characteristic of data need to be maintained separately. So the program and the data will be dependent on each other. Each department or each division has set of programs, set of files, and the set of metadata associated with in each of these contexts, right? So that is one of the disadvantage of having this, because what will happen is, if in some case, if you want to change, for example, if a customer says, um, if for some reason, if I wanted to change the customer, maybe details, or maybe customer name field need to be increased by, say, from 10 characters to maybe 100 characters for some reason, we need to actually do changes in each and every system where the customer file is associated, because they individually maintain it, right? As well as we need to update the metadata as well. So that means the program and the data is dependent to each other, right? So you can see there are a lot of maintenance work we need to do, right? So if there is update here, we need to update this, update that as well, right? And also you can see, if you maintain separately the files in this sort of environment, the duplication there of data is unavoidable, right? So customer data is appearing in here in the order department, as well as accounting department, right? And also the product details or product related information are also duplicated in the order department as well as accounting department. So the duplication of data is everywhere, right? So we need to maintain the duplication of data. So what will happen if we have a duplication of data? There can be a lot of errors can be happen, right? Because the same data maintained, because there's no single truth in this particular system, okay? So that is another major disadvantage. And then also it will give a kind of another disadvantage, like it limits how we share the data, because each of these systems won't compatible to each other, right? So in order to share the information, we need to have a kind of a conversion process, right? So we need to convert everything into one kind of a system, and then of course we can produce something that everybody can understand. That's a kind of another additional burden for organization. So there's no centralized control involved in these data maintenance, okay? And the length of development times also increases, because when you create these data separately, you can see the programs and the data are dependent of each other, and then the metadata is also dependent on the context as well. So the development, so if you wanted to develop a certain other program, so each department, the development times actually increases, because we need to freshly create the metadata and the set of files to relevant to that particular application, right? So that is another disadvantage of keeping these separate files, or maintaining this sort of file processing environment in the organization. So that all these can be lead to excessive program maintenance, because we need to maintain not only the programs but also the data, as well as the metadata associated in each of these program areas. So what it says is 80% of information system budget probably consume or utilize to maintain the data, rather than we expense it for develop the new programs. So that is what the research says. So Pine Valley Furniture Company, it's a fictitious company. Sometimes I may use some of these information related to the Pine Valley. So this is how they are earlier system looks like. Right. So, in order to overcome these disadvantages, as I mentioned in this slide, that is why we have a database approach to overcome these disadvantages, right? So, in the database approach, what we actually do is we need to have kind of a central one database. So the applications can be actually share these central information among themselves, right? So in order to think about all these databases, we need to actually think about the concepts associated in creating these centralized databases or database approach. So the first concept is the data model. Now the thing is this: when you're trying to build a database or database approach to keeping the data and information, what we need to do is we need to create a kind of a data model, right? So we need to think about what sort of information involved in that particular context, how the information are related to each other, etc., etc. This can be done by creating a kind of the model. So that is called the data model, right? So it's a kind of a graphical diagram. We try to capture the relationship between different objects and the different events in that particular context. So when it comes to the data models, also we can actually categorize the data models into basically two types. The first type is called the enterprise data model, and the second type is called the project data model. So sometimes when you now first thing is first we need to have a kind of a broader view of the context, what context we are going to build this database. That is what we mean by the enterprise data models, a high level view or bird's eye view of the data you are going to use, a bird's eye view of the objects you are going to use and the relationship associated with these objects. So that is what we mean by the enterprise data model. And then from the enterprise data model, we can develop the project data model. So that means when you break down the enterprise version or enterprise view of data, we can actually develop more detailed view of the model of the database, right? So we give a kind of specific structure, specific context, and then we can develop the project data model. So in this particular semester in this subject, basically we focus on the project data model. How we going to build a project, the kind of a database for a given particular context, right? But of course, we need to have a kind of a bird's eye view as well, because we should know what context this particular database going to build in. So that is what we mean by the project data model, right? And the next important thing that we need to understand is when you develop these data models, we often come across this term entities, right? So entities actually is where we now, as I mentioned before, we build the databases because we are interested in capturing some information related to some objects or events or concepts, right? So these objects objects or concepts or relationship, sorry, objects or concepts or places, we call it as entities in the database terms, right? Entity. Sometimes we can call as files. Sometimes in a day, in our normal daily word, we use the word called file, right? So that is what we mean by the entity in the database terms, right? So that when you have the entities, of course we need to actually further classify the entities into different terms as well. For example, we need to think about what kind of characteristics associated in all of these objects, right? These are called the attributes. So don't worry, these things we will revisit again. I just quickly going through it and I'll come back to it again, okay? So these are called attributes, right? So when you describe these objects, events a little bit more in detail, these characteristics are called attributes, right? So entities have attributes. Entities represent objects, events, concepts, persons, etc., etc. And then it's not only that, because once you build the entities, once you understand the entities or the objects, we need to understand how these objects are related to each other, because objects or entities itself will not give a kind of any meaning for the companies or the context we are dealing with, right? So we need to put a kind of a relationship between these entities. That is where the relationships comes into place, right? Um, so we need to think about the relationship between the objects, how these entities are related, or how these objects or places or events are related to each other. So some objects can be related to each other in one and many ways, or one to many ways. So that is what we mean by this one to many. For example, if you think about this example, now think about this. So I'm interested in capturing the details of the customers and the customer orders, right? So I have two objects, right? Customer object and the order object, right? So what is the relationship between the customers and the orders, right? For example, if you think about a one customer can order many products, right? So then that means there is a one to many relationship between the customer and the order. So one customer can place many orders. But if you think about one order is related to a one customer, right? And also there are certain many the products involved in the orders as well. So product is another object in the database context, right? So one product can have many orders, right? And one order can have many products, right? So likewise, we can build that relationship in our databases if you know correctly the logical how this logical relationship works in the real world. Right, so this is called a kind of, this is how it looks like, the enterprise data model. And then the enterprise data model, as I mentioned before, we can convert into a more project focused data model. So because we now this is a conversion of a project model, so you can see we have the additional details placed in each of these entities, right? So for example, these are the characteristics of the each entities or attributes of entities. So likewise, we can actually go and further we can, you know, break down this project data model into smaller models as well, right? Right. So, so these are the small things that we need to learn. So we know when you come into a database approach, we have entities, we have relationships, we have certain attributes, etc., etc. So these are the things that we need to learn when you develop a database. Okay. Now there are so many database architectures or technologies, I would say. The database technologies in nowadays. One of the main actually very popular technology of the database is called the relational database technology, right? This is what we are actually learning in this semester, this technology, right? So in the relational database management or relational database technologies, we try to organize the objects or the link the objects in a way that we can represent. We put a kind of a connection by having a common values in a related table. So how you're going to establish these common values in the tables is what we are going to learn in this subject, right? So in order to establish, we need to have a common value. For example, if you think about the customer order, we definitely need to know who the customer is placed this order, right? So there has to have some kind of an association between the customer and the customer order, right? So how we're going to link that association. So we link that association probably maybe using a customer ID, right? So if you place the customer ID in the order table or the entity, probably we can see we can have that link more meaningful, right? So we know exactly this order placed by this particular customer. Then if I know that customer, I can actually see their names, their addresses, etc., etc., right? So similarly, each product or each order can have many order items, right? And you can see these order items entity or the object link with the order ID. So you can see the order ID 1001 have many items ordered, right, in that particular order. And then that order item actually related with the particular product that company is selling, right? So company can sell many product types, many product varieties, right? So in this case, in our fictitious company, Pine Valley furniture manufacturing company, they are manufacturing and selling some furniture products. So you can see there are many varieties of products here. So how we going to link this order line with the order line with the product is the product ID, right? So product ID has to have appeared in the order line entity, right? So then we can have a kind of meaningful link within. So this model is called, or this technology we say is called the relational database technology or relational approach to databases, right? So this model is actual. Now see, now in a traditional file processing system, if you keep the information separately, so this kind of approach is very difficult, isn't it? Because we can see it's a kind of we can actually still, but then we have to have a separate relational system for each and every system. But if you have one centralized place to put all these data, so we can easily construct this sort of relational kind of model and then implemented it in one central location where all the applications can access the information. So you can see if you build this kind of database, the information is not redundant, right? So we have only single truth of information, right? For example, customer details are not repeating. It's placed in a one file called the customer file. Order details are not repeating. It's placed in a one file called order file, right? Similarly, the product details are not repeating. It's in the same one single file. Okay. So this is one of the advantages of database approach. So there are several advantages associated with the database approach. You can see in that case the program and the data is independent of each other. So the data is not dependent on the program itself, or we have separated the database or the data files programs itself. And then that means we need not to have a separate metadata to be maintained in each program, because now we have separately maintaining the database, so we can have one centralized repository to maintain the metadata or the data about the data as well. So that is very easy, isn't it? Redundancies can be reduced because you can see that we have only one single truth data about the customers, orders, products are separately maintained. So we can have a kind of, even if you wanted to have a redundant information, we can plan it very carefully what kind of information can be redundant, right, in which files, etc., etc. Okay, so that is another advantage. So this will actually give a consistency between the files as well. Data can be improved because of the consistently maintained. So there is no duplication, there is no kind of prone for the errors. So the consistency will be improved when it comes to the databases. And also it will improve the sharing. Now earlier, can you remember, as I mentioned before, if you wanted to share the files, you need to actually convert these information into single kind of system, because otherwise other system can't read it properly, right? So, but this kind of environment, if you maintain all the information in a centrally managed database, the sharing is possible because we have a central location to keep all the data. So, and also it will increase the application development productivity as well, because we need not to maintain actually separate metadata repository because the application, programs, and the databases are separated to each other. So the developers can actually focus on the application development side rather than worrying too much of the database aspect, because they exactly know what kind of data is collected, how the metadata looks like, etc., etc. Therefore, the productivity of application development can be increased, and that also give a kind of sort of advantage for the organization, because they can actually specifically enforce some sort of standards, how the data is governed, how the data is managed in the organization, because we have a centralized location where we can actually manage the data more effectively than spreading up the data everywhere, as I mentioned before, right? And then it will improve the data quality, because we are maintaining one single repository. Even if the customer address or the customer names change, if you want to increase one specific part of a file or the entity, we can do it centrally in a one single place rather than updating all other files, etc. Right? So definitely it will improve the quality of the data that organizations are maintaining. And then the accessibility of the data increase as well, and the responsiveness of the company will be increased, and this will actually give a kind of additional competitive advantage for the organization, because they don't want to actually spend time to convert data and then waiting for the until it will converted and then generated some additional information. So the responsiveness can be increased because of we have central place to maintain all the data. Reduce program maintenance, yes, because now programs have been separated from the databases. Metadata is separately maintained, so we don't need to worry about the programming maintenance. We don't need, because the centralized location give an additional advantage. These programs are separately maintained, so we need not to worry about updating all the programs associated with different files. And of course, then it will increase the decision making structure in the organization because of all these stuff, because of these advantage. So these are the basically advantages of database approach, why we going ahead database rather than keeping separate file system or file processing systems for different organizations. But same time, even if you move into the database approach to keeping all these information and data, there are some costs and risks involved in this approach as well. The thing is this, we need specialized personnel in this kind of, because now we maintain databases separately, we maintain metadata separately, we maintain program or application related to database separately. So there is a highly need for specialized people who are specialized in these approaches, or who are knowledgeable in maintaining the databases, right? So that is the reason I'm telling you there are a lot of opportunities available, because the databases are getting more complicated day by day, as I mentioned before. Now organization need to deal with more unstructured type of data, right? Social media data, tweets that people are exchanging, multimedia data. So all these complications will actually demand a lot of specialized people to involve in creating and maintaining highly specialized databases in today's highly competitive environment. And then the installation and management cost is also a little increased because of these highly sophisticated data that we need to maintain. So nowadays there are so many cloud-based systems available, and the main important thing is how you going to protect our databases. So these protection or security actually give kind of more need for the specialized people to manage all these databases. So the complexities are very high when it comes to maintaining the databases. Conversion cost is another thing that, as I mentioned before, because we have a lot of types of data involved in today's business organization, so we need to actually find out how we going to convert these different kind of data to a kind of a where we can understand and share with the different applications. And also we need a kind of a explicit backup and recovery plans in place when we have databases, because databases are the vital source of it. I think I would say if you lose the database one single day, sometimes business will be wind up with the world as well, because that is very important, right? The nerve system of any organization is now becoming the databases data, right? So imagine the Amazon or Alibaba or whoever deals in the online space, if they, if the database fail to operate in 1 hour or 2 hours, how much of cost, how much of loss that they will make, right? So we need to have an explicit backup and recovery strategy in place, um, in order to keep databases running as well. So the main problem is nowadays is to manage this organizational conflict, because if you maintain centrally located database, then of course we know that everybody is accessing the data. How are we going to manage these conflicts between the different organizational units? That is something that actually we need to think about, because this is when I work in the industry, this is one of the main difficult parts. Because other stuff actually more technical oriented is very easily sort out if you have enough resources. But this part, the organizational conflict, is where the hardest part, because people sometimes some managers, some department division, they don't want to share their main important information with the other department. Even they think that they will lose the control of some part of the operation, so they don't want. So how are you going to manage it? That is another important thing that we need to think about in the modern database way of keeping the information, right? Right. Therefore there are so many components involved in a database. To keep the information in the databases. So the first thing is, as I mentioned before, we need to have a kind of a data modeling and design tools, right? So we need to have tools. So we need to design the database. We need appropriately automated tools. So design the database. And also, as I mentioned before, we need to keep the metadata separately. So we need to have a repository to centralize or centralize place to keep all these data about the data. And then we need to think about the database management system, what kind of tool we are going to use to access and manage or manipulate our databases, right? So that is what we mean database management system. And then of course the database is where we store the information on the data. And then we have application programs, right? So application programs are the ones who constantly access the data from the databases. So that is a part of the whole system that the organization uses. And then we need to think about the user interfaces, graphics, displays, menus, etc. We are using in different applications to access the data. So that is another part of the database as well. And then the professionals called database administration or data administrators has to be established, because they are the one who responsible for maintaining the databases. They are the one who giving the access and then giving sort of all these maintaining part done by these administrators. And then we have the system developers, right, in place, designing databases. And then we have the users, people who are using. So you can see when you're developing a database, so there are so many things associated in this particular database environment. It's not only the database itself, right? So other things need to be considered as well. So these are the areas actually we need to consider when you're developing an effective database. Right. So when you are designing a database, it actually involves a lot of planning as well. So it has to go through a kind of, it's not we just develop a database. It has to go through a certain steps, right? First, we need to define the develop the preliminary purpose or the preliminary understanding of the business or the situation, and how the information systems might help to solve the problem or make opportunity possible. So that is what you mean by the planning. Planning has to be done before we develop anything, right? So in this case, at the planning stage, of course, we develop two types of probably two types, I would say two types of database models. Okay, so we call, one is called the enterprise model, one is called the more conceptual model. Enterprise model is where we analyze the data requirement. So it's kind of a bird's eye view of the data requirement for the organization. And then we have the conceptual view of the data model, which identify kind of the requirement, specific requirement for the kind of a proposed sort of system we are going to develop, right? So we usually develop these models in when it comes to the planning stage, and then we have the analysis stage, right? So but the purpose of the analysis stage is to elicit and structure all the information requirements to develop to a particular database for a given context, right? So here we develop this so-called conceptual data model a little bit more in detail, right? So we develop the preliminary conceptual model, and then we compare this preliminary conceptual model with the enterprise model, etc., etc. So there are certain steps involved in this as well. And then it comes to the design stage, right? So in the design stage is where we develop the more logical data model, we call the logical model, and the physical model. We decide which technology we are going to implement the database. So based on that technology, we develop the logical and the physical model as well. For example, physical model based on the technology used. For example, if you use the Oracle, we develop the physical model suitable for the Oracle, right? If it is MySQL, we develop the physical model suitable for the MySQL, etc., etc. So that is what we mean by the design. And then, of course, we implement it. So we write the programs, we build the database, we testing it, we install the new system, we train the users, and then we finalize all the documentation, etc., etc. So it's done by the implementation state, right? So this is where the coding and testing comes into play. And then, of course, the maintenance part comes next, because we need to monitor the operation and the usefulness of the system once it gets implemented. So that is what comes under the maintenance. So database maintenance is another huge developing area. There are a lot of jobs involved in that particular area as well, because we need to analyze the databases, applications, to ensure that that evolving information requirement can be met in the given our application or the databases that we have placed in the company. So likewise, you can see database development is a kind of it's not a kind of we just develop something or just go and program something. So there are a lot of stuff involved in this particular the content, right? So there are a lot of phases we need to actually go through developing the databases. Okay. Right. So when we're developing databases, basically we usually use the three schema approach. So different people have different view of the databases. That is what we try to take into consideration when we develop the databases. So when you develop the enterprise data model, we call the bird's eye view of the data model. Then, of course, based on that, we develop these so-called three schemas, right? external schema, conceptual schema, and the internal schema, right? So schema is way of implementing the database into a specific context. That is what we mean by the schema. How are you going to describe it in a specific context, right? External schema means what are the different views, because the databases can have a different views, different users. I would say different users have different aspect of database. For example, if you think about um, management requirements, their requirements are different to the normal typical users requirement, right? So we need to develop these schemas, we call external schemas, based on the view of the database. And then also, if you think about the developers, they may have a different views as well. And then of course we convert that these external schema to the conceptual schema. We develop the more rigorous database model based on the enterprise data model requirement. And then we convert into the internal schema, where we actually implement, we not implement, I mean, where we develop the database suitable for the particular database technology or the context that we are trying to implement. So we have kind of two schemas, logical schema and the physical schema. So based on the different technology, we develop the logical schema, and then we convert it into physical schema. So maybe Oracle, MySQL, etc., etc. So it is what is so based on that technology, we convert the logical schema into the physical schema. Right. So yeah. So the basically. So database administrators who are developing these databases are the one who actually determine which schemas we are going to use in a specific context, especially when it comes to the external schema. Right, so that is something bit technical. I would be not going to in such a deep, but just wanted to give you a kind of bit of taste before we move into our subject. So the database systems, as I mentioned before, it's evolved in a past decade, and it's driven basically by four main objectives, right? So these are the four main objectives why the organizations or the enterprises use the database way of keeping the information or the data. Need for the program data independence, because they realize, as I mentioned, because we need to separate programs and data dependent on each other, right? So if you dependent on each other, programs and data, it will give you a lot of headache, a lot of troubles, as I mentioned before, because metadata needed to be developed each time when the application has been developed or application has been changed, right? Or the database has been changed or the file has been changed. So we need to actually get separated these two, because then it will give you a kind of added advantage to reduce the maintenance as well. So that is one of the main advantage, main objective why we need the database approach. So a desire to manage more complex data types, as I mentioned before, more unstructured data is nowadays coming into place. So it's very difficult to give a specific structure for these unstructured data. We don't know how the people are sharing the tweets, or we don't know how people are sharing what kind of information in their social media, right? So we need to have a kind of a separate technology. So we need to separate the databases with keeping the separate databases to handle all these kind of complicated matters. So that is another requirement why we go ahead with database systems. Ease of data access for less technical personnel, that is another thing, because nowadays more non-technical oriented people are coming into play in organizations maintenance of data, specifically the accounting people, right? The accounting department, maintenance department, marketing people, they also now lot of interactions happening with the databases. So because of this, non-technical people are coming into play. So there is a way of keeping the databases. There is a way of implementing the database. So we need to, that is one other driver for why we go for modern database technologies. And also the decision making, right? So nowadays the change environment is changing rapidly. Competitive advantage is something that organizations to grab very without delaying anything, right? So need to make decisions at the right time, right spot, right? So these powerful decisions can be made only if you have the related database technologies in place in the companies, right? That is one of the main key aspects, I believe, why we need the modern database technologies in the companies. So these are the four basically four ideas or four main objectives why companies are preferred databases rather than the individual files to maintain their data. So here I have given a kind of evolution of how the databases evolved. 1960s, very files type of data, and then hierarchical. It actually died around 1990s. So data keep in hierarchy pattern. And then the network type of databases develop in there, and then it also died. But the relational database is what it started around late 1980s, but then it's still actually we are using these relational database technologies. But nowadays there are more other technologies have been evolved, specifically when they develop these object-oriented programs started to evolve in 1990s. Then that technology has been integrated into the databases to develop more object-oriented databases. And then it has been kind of, then people realize, okay, there's a hybrid way of keeping the databases, like mixture of relational and object-oriented. So these technologies have keep evolving, but nowadays big data is one of the key main important thing, because as I mentioned before, the uh, most of the devices are becoming more intelligent, right? We are talking about IoT, so Internet of Things, right? Even our fridge can talk nowadays, right? Our smartphones, smart devices, all things are smart in the organ, even in the houses, right? So because of this, we need to have a kind of big data technologies come into play, evolve, and it comes into the databases as well, right? And as well as data warehouses, so analytics. So data analytics are the intelligence. So intelligence has to be generated by the databases to make decisions more effective. That is another hot topic. It's actually developing rapidly as well. So you can see kind of there are so many technologies involved in the databases, different ways of keeping the databases. But the still structured or traditional approach is still in place. It's still very popular, this relational database. In this unit, we will majority of the work we are doing is relational, but we'll do a little bit of analytics and big data later on the semester. But we are not going to touch in object-oriented databases in this particular unit. Right, so these are the technologies, I would say, or the architectures of the databases we can use to maintain or create the databases. So a hierarchical data model is where we can place all our data in organization in a hierarchical structure, or maybe we can place it in a kind of a more network kind of area. So that is called the network database models, right? So they kind of we related to different data, objects in based on their relationships. And then we have these relational database models is where we put a kind of we establish the relationship based on the common key between the objects, right? That is what we are learning here. And then this is what we mean by the object-oriented database model. So the object-oriented models, we first focus on the objects, and then we try to have the attributes or the behaviors associated in the objects. We create that behaviors, and then we build the databases based on these attributes. And then we have, as I mentioned earlier, more what do you call this, data warehouses or business intelligence types of applications. So they have a kind of architecture, something like this is called the multi-dimensional database model, or sometimes we call it as a star schema view of database. This is another technology. We'll actually do this little bit later on in the semester. And then big data, this we can't have a kind of a structure in the nowadays, right? So databases, as I mentioned before, because data can be generated from different sources, intelligent sources, right? Smartphones, maps, social media, tweets, etc. So different. So we nowadays in the modern world we can't have a kind of a structured way of keeping the data. We can't give a specific structure. So there are so many big data technologies involved in how to handle these sort of unstructured data. So that is another thing that we will learn later in the semester as well. Right. So as I mentioned before, basically this unit were focusing on relational data model. So when it comes to the relational data model, we need to think about entity relationship model. So as I mentioned before, we need to build our data model first before we model or before we build our database, right? So entity relationship model is very important. So we develop this entity relationship model uh, using entity relationship diagram. So basically, entity relationship model means we trying to get all the objects we are trying to build in our database and make sure that it related to each other. So when you come to relationship, when you build a relationship between these different objects in the company or the context or the business we are going to develop the database, the one of the important thing we need to understand is the rules governing these relationships. We call it as business rules, right? So every organization has the rules, right? Rules. For example, think about you. Now, in university, we have rules, right? So, for example, a student can enroll in maximum, say, 4 units in a given time. Now, that is a rule, right? Did that rule going to impact the database? Yes, of course, because if you think about the object like student and the enrollment like another object, right? So the link between these two objects can be governed by that business rule. So we know how many times the student can appear in the enrollment, right? So that is those are called the business rule. Of we need to actually think about that when you're building the databases. So how we are going to build that the model entity model or the data model by using the diagram called entity relationship diagram. So it's a graphical representation of entity relationship model, I would say, right? So it is a kind of a specification how we going to use the data, how we going to store the data, how we going to use the data, manage the data in a given context, right? So eventually we build the database using some form of technology using this entity relationship diagram, right? So there are so many other ways we can build the database, but this is the easiest way that we can learn, right? So we will learn another method to develop the database probably in week 7 or week 8. I will teach you that as well. It's another approach rather than entity relationship approach, okay? Right, so this is a simple entity relationship model. I would say database model or entity relationship model or data model, I would say. So think about, right, so think about we are trying to build a small information system for a company which maintains movies, right? So think about in that case we have a kind of we trying to build two we're trying to capture the information regarding two things, right? So we have movies, so one object, and we have ratings. So for example, movies have different ratings, right? Movies have ratings. So by the way, sometimes now this is one thing that we need to be very careful. So the first thing is when you're developing a database, one important thing is we need to first classify or clarify which objects we are going to capture the information. So in this case, there are two objects, the movies and the rating related information, right? And then what we can do is we can actually think about, all right, what are the characteristics associated in the movie and what are the characteristics associated in the rating. So these are called the attributes, right? For example, movie, we need to capture the movie numbers, the titles, and the year the movie has been released, right? So same time, the ratings, we are interested in capturing the rating codes and the description of the ratings, okay? So what we have done is now we identify two objects, and then what we can do is we can then realize, okay, what is the relationship between these two objects, right? So movies and the ratings, right? Movies and the rating has a relationship, yes. So every movie has a ratings, right? And if you think about one rating can have many different types of movies, right? So remember, the movies have different ratings, right? PG, M, etc., etc. So we have rating. When you watch the TV movies, you can see they have put these rating codes. Yeah, right. So this is you can see sort of this line, green line. This is the relationship, right? So just ignore these small kind of crow's foot, we call crow's foot here, and this particular line just ignore for a moment. I'll come to that little bit later on. So we have the objects. So objects are represented in these boxes, right? Rectangle boxes, right? So this is called the entities or the objects, right? So we have two objects here, and these balloons are the characteristics or the attributes, okay? Characteristics or the attributes. And this green line is the relationship between the objects, right? So these two things are very important. Right, so entities, what do you mean by the entities? As I mentioned before, this is an object or anything that we like to capture the information. That is the first thing. We need to clarify that, right? So in this case, we have two entities. For example, here we have subject and the lecturer, right? Now, this is another example I'm going to, okay? So think about this. So we are trying to capture some information regarding the subjects, different subjects, and different lecturers who are delivering that subject, okay? So then the next thing is we need to think about the characteristics, right? So what are the attributes or the characteristics of these two entities we are interested in? So in this case, I have identified three characteristics for the subject and three characteristics for the lecturer. For the subject, subject codes, title, and the credit points. And the lecturer, lecturer ID, lecturer name, and the age. Okay, so there are 6 characteristics. 3 goes there, 3 goes there. So 2 entities, right? So we now know what we mean by the objects and the character attributes. Okay. And then we have the relationships. So we need to establish, right? Then once we clarify that, we need to see, okay, what are the relationship between these two? Now remember, when you decide the relationship, we need to name the relationship, right? So we know subjects are delivered or convened by the lecturers, right? So convene relationship. So there is a relationship. So we establish that relationship. Okay. What we can do is now, it's actually very useful. Now these are the steps actually, I would say, right? So when you're designing the databases, first we need to decide the entities, then these attributes, right, or characteristics of the entities, and then the relationships between the entities, right? And then what we can do is we can put some test data and see how it works, right? For example, if you think about the subjects, we can have many subjects, right? So in this case, today, this semester, you are enrolled in 4 subjects, right? So INF10004, INF10009, etc., etc. And you can see here I have put some data here which has 3 types of data which represents the 3 attributes that I have placed in the subject entity, right? So INF10004 is the subject code. Database analysis and design is the title of the subject. 12.5 represent the credit points. So you can see now here we have two subjects, right? Now, usually in these now if you have two subjects here, we in the databases we call the instances. So two instances. This is instance one, this is instance two, right? So likewise in the lecturer uh, entity, I have two instances as well. Lecturer ID 207, that is this one. John Smith, that is the lecturer's name, and the age 37, that is the age of the lecturer, right? So these representing these three. So these are the instances of this attribute. So I have two instances or two records or two instances in this particular entity. So one of the important thing that, as I mentioned before, when we are developing the entity relationship or the business model or the logical data model, is to understand the business rules, right? So there are so many business rules in the companies, right? So these are the examples of the business rules. For example, a student must only be enrolled in one course at a time. We can have that business rule in our university, right? A student may enroll on many subjects at one time. A subject must only have one convener. We can't have multiple conveners for a subject, isn't it? We can have only one convener for one subject, right? So that is a business rule as well. So why we learn this business rule? Because this business rule actually impact how we govern these data, how we design these databases, right? So in other words, this business rule actually impact how we're going to establish these relationships. That's what matters actually, business rules, okay? So business rules, how we derive these business rule, because it comes from the organization policies, procedures, events, and functions. Um, and actually these business rules give a kind of a structure for the database we are going to build, right? And also these business rules give you kind of an idea how the organizations are behave or how they control the specific operations, right? So therefore very important to capture business rule. Any database development activity, the one thing that I would consider is most important is capturing this business rule, because otherwise you totally implementing a different database which is totally irrelevant for the given context, right? Yes, so we automate all these business rules using databases, using database management system software, right? So that is the ultimate objective. So when it comes to the business rule, there are some characteristics involved in a good business rule. It has to be declarative. It has to tell you what is actually happening, what is actually involved, not how is going to happen or how to do that, right? So the rule has to be very declarative. And it has to be precise. It has to be, that means very clear. It has to be agreed upon, and the meaning has to be precisely established in the company. That is another important thing. Otherwise, if we have very vague business rule, it's very difficult for us to implement in the required databases, right? And it has to be atomic as well. That means business rule usually described in a one statement. We can't have kind of a multiple statements, or like we writing kind of pages and pages for one business rule. No, it has to be one single precise statement. It has to be very consistent, internally and externally consistent. It applies in a very consistent manner across all the situations in the organization. That is what we mean by the consistency. That is one of the key attribute, I would believe. Expressible, it has to be structured. We can express in a natural language, because we can't have very vague kind of rules, because otherwise it's not, it can be different meaning for different people, right? We don't want that to happen in the company. Everybody in the same page. How are we going to keep that everybody in the same page using same business rule? It has to be expressed in a structured new natural language so everybody can understand it clearly. Distinct, non-redundant, it has to be distinct, it has to be very, you can't redundant. Any information contained in the business rules has to be very specific. That is what we mean by that. And then any rule that you generate or write or implemented has to be business oriented, business focused. Okay? That is another characteristic. Right, that is one important thing. Right, now most important thing with when it comes to building the database is so-called the cardinality of the relationship. Now remember then when you develop these databases or the objects, right? For an early example, we identified two objects, right? Lecturer and the subject, right? Lecturer and the subject. So how are you going to establish the relationship, right? How are we going to that how are we going to establish that? That is called the cardinality of the relationship, right? Um, so cardinality of the relationships between the objects can actually group into three categories, right? So we can have one-to-one type of relationship, right? So each entity or each object in our model has a one exactly uh, related with one exactly one type in the other model, right? Or other entity. That is what we call one-to-one kind of relationship. For example, I can see one employee can have one parking space in the company, right? We don't have multiple parking spaces allocated for us. You have only exactly one parking space, right? So if you think about the employee and the parking space, we have one-to-one kind of relationship, right? So how are you going to show one-to-one kind of relationship between the diagram? So we usually, you can see in here my pointer. So employee and parking space. So this cardinality we establish using this single line, one and one, right? So one employee exactly have one parking space, and one parking space belongs to one employee, right? So that is what we mean by it, okay. So remember that is what we mean by the cardinality. So how one instance, in other words, cardinality means how one instance in the employee table belongs to instance in the other table, right? So one employee or one row in this table has exactly associated with one row in the parking space table. That is what we mean by one-to-one. Okay. So how are we going to show it in our diagram or the model? This is how we show it, right? So two single lines like this in the relation line, right? So remember, you need to write the relationship, you need to link the relationship, and you're going to put these cardinality, right? One-to-one. So the other type of cardinality is called the one-to-many. Right? One-to-many means one instance in a one table related with many instances of the other table. That is what we mean by one-to-many. So how are you going to establish this? This is how we establish that, right? One-to-many. Okay. So for example, if you think about one product, now remember that earlier example I told you, one product, one person can order many product, one order can have many items in that product, right? So that is what we call the product line, many items, right? So so if you think about one item or one item or product line, um, um, will associated with or one product line can contain many products or many products, right? Or in other words, one product is associating one product line in my product line entity, right? So the many means because if you think about product lines, right? So different orders can have same product line different places, right? So that is why we made many. So how you establish many here? So we show it in this sort of, we call it as a crow's foot. You know the crow, the bird crow. So how we show it by using the crow's foot. Okay. So what do you mean by this? Many means one instance or one record in the product line can associate in many records in the product table, right? That is what they mean by the many. But if you think about one product, right, or one specific product is have one association with one product line, right? Okay, that is what we mean by that. So now remember, when it comes to the cardinality, it has to go both direction, right? So left to right, right to left, right, left to right, right to left. So that is what we mean by one to many. Okay. Um, and then the third category is called uh, many to many, right? Shenal, you have the question. I'll come back to you. I'll give you another example. Okay, let me explain this first. The third one is called many to many. Many to many means this is an example of many to many, right? For example, one student can enroll in many courses, and one course can have many students, right? Right. Now, one important thing that you need to remember is when you expressing the cardinality, or that means the relationship between the instances, always start with one. Okay, always start with one and go in the both direction, left to right, right to left, right. So one employee is assigned to one parking space. One parking space is assigned to one employee, right? So likewise here, one product line contains many products, right? One product can have many product lines. So one product can have only associated with one product line. So here, many to many, one student can register in many courses. One course can register by many students. For example, if engineering IT diploma, we can have many students, right? Right. So one course can have many students. So how many students we have in this semester? Here I can see around 11 or 12 students, right? So one course can have many students. So that is why we have many here, right? So opposite, always in the opposite direction. So one here, opposite to here. Okay. So one student can have many courses as well, right? So one student can have, because you can study many courses in the Swinburne, okay? Many courses in the same one. That is what we mean by this one to many means in this side. Right? So if you think about this, this have many to many, right? Because we can have many students associated in many courses associated in many students. Right? So these are all the cardinalities, how the relationship or how the instances of each entity related with the instances of the other entity. That is what we mean by the cardinality. So when you establish the relationship, we must establish these cardinalities, because this is where the business rules come into play, right? We establish the business rules in terms of the cardinalities, okay? That is very important. So the Shenal, you asked me to explain another example, like here, right? So one to many. Now think about something else, like um, let's say, okay, so think about something, some example. Let me think. Say for example, say one song, right? One song have many song categories. One song category can have many songs, right? Something like that. So I'll come to that later on. I'll give you some more examples, but don't worry. I'll come to that a little bit later on. But think about think about these three things, right? Cardinality relationship. I'll give you more example in other. We have more examples in slides. Right. So that is about the cardinality relationship, and then cardinality constraints, right? That is another important thing. So once you establish the cardinality relationship, we need to put the cardinality constraints, right? Now, cardinality constraints is we are limiting how many instances can, related to other instances in the other entity. That is what we mean. That is what we mean by the constraint. Constraint means we are limiting something, yeah? Limiting something. So if you limit the cardinalities between the entity, that is what we call the cardinality constraint, right? So we have actually two types of constraint. We can have optional constraints. So use optional means can or can we have, can or maybe or something like that, right? So we use a circle to show that. Okay. Or if you have the mandatory, that means must. If you must participate in something, right? So if it is mandatory, we use this hash mark or a single mark. Now sometimes it bit confusing because some people, because remember earlier, the cardinality relationship also have a hash mark, right? If you have a cardinality constraint, there is another hash mark as well. If it is a mandatory, okay. Now here you can see in this case, right? Now here we have a cardinality relationship with the cardinality constraints, right? So cardinal relationship, what do you mean cardinal relationship? Something else, right? Cardinal relationship is means how one instance participate in the other instances, okay? Cardinality constraint means how we limit that participation, okay? Right, for example, in this case, now think about this example, right? One patient can have many patient records or patient history records in a hospital, right? So that is called the participation cardinality relationship, right? One patient record can have many patient history records in a company or in a hospital, right? So we have one here, we have crow's foot there, okay? But again, we have this cardinality constraint established here because what it means is one patient must have one or many patient history record. Because if you have a patient in a hospital, that patient must have at least one patient record, right? You can't have a patient record without having patients, right? So that is what we mean by this one, right? This is called mandatory. So mandatory has to be there, right? Mandatory patient record has to be there at least for one person, one patient. So he or she can have one or many patient history records in the hospital, right? That is what we mean by this. Okay. Um, so if you go, this is left to right, right? Left to right. But if you go right to left, if you have one patient history record, that patient history record must belongs to one patient, right? You can't have any patient history record without associating any patient, okay? So that is what we mean by this mandatory in here, okay? So you can see there are two mandatories in both directions. So that is called the mandatory cardinalities, okay? The mandatory must. Right, so optional cardinalities means, or optional cardinality constraint means maybe, can have or cannot have, right? For example, think about this, one employee, right? One employee uh, may have assigned to many projects, may have assigned to many projects. So that means we can have employees without assigned to any projects as well, right? Because it is made, right? Right. But if you have the projects, right? If you have the project, if you have project must have at least one or many employees, right? You can't have project without having employees, right? You must have one, at least one or many employees. So that is what we mean by this, right? Mandatory many. Right. Right, but if you think about the cardinality relationship, it's a many-to-many relationship because one employee can assign to many projects, one project can have many employees, right? Right, and here you can see we put the cardinality relationship and cardinality constraints. Right, so this is the modeling part. Right, so if you take that to our example, what we have discussed earlier, the subject lecture example, Now, Shenal, this is an example that you have asked, right? So one-to-many example, right? So if you think about this, one lecturer can convene many subjects, right? One lecturer can convene many subjects. One subject, how many lecturers convene the one subject? How many conveners we have in INF10004? One convene, that is me, right? So one subject convened by one lecture. So that is the cardinalities, right? That is the cardinalities, how we is associated with this. Okay. Now remember, as I mentioned before, always cardinalities between the objects has to be expressed in both directions, left to right, right to left. Okay. So, and always think about, always start with one. Okay, so don't think about this before that. Just start with one subject conveyed by one lecture. Now always the cardinality has established in the opposite direction. So one subject convened by one lecture. One lecturer convene many subjects. So I can teach many subjects. I have actually convening two subjects in this semester. So me, myself as a lecturer, convening many subjects. That is what we mean by this. Okay. Now I know that this is a little bit sometimes very difficult to grasp, but don't worry, we'll go small step by step. Okay. So I don't want to go rush and do everything. So I may not able to actually complete all the slides today. So I'll start it next week. Okay, so don't worry. Right. So that is about this. So cardinality relationship. Kunjal, you have a question. What is the difference between one to many and many to one relationship? One to many. So one to many. One to many. This is one to many. This is many to one. One to many in right. So one to many means one lecturer convene many subjects, right? That is what we mean by one to many. Many to one means many to one, other side, other way. One subject convened by one lecture. Okay. Now, sometimes when you confuse, because when you always start with one, because if you start with one, then the confusion will not going to be happen. Okay. So I will actually show how you to draw this one, right? So don't worry, at this time you make a bit confused. When you draw the diagrams, when you read the context and draw the diagram, I will re-explain this concept when it comes to the tutorial, okay? But you need to remember the basics. Right, so remember I told you what we mean by the entity instances. Sometimes we can, in a plain way, we can say the instances are the records, right? The records we are recording in the entity, right? So here I have put in the lecturer table, I put some test data in this case. So I have two instances, right? First lecture ID 207 and lecture ID 119. So two instances in the lecture. Okay? So the instance is a set of values that represent these attributes. Okay? Right. So one of the other important thing that we need to remember is the identifier. Now what will happen if I put the lots of instances in the lecturer table? If I record, say, millions of records. So if I have, no, we don't have millions of lecturers, but think about, okay, we have 60 lecturers, right? If I have 60 lecturers, how can I uniquely identify each lecturer, right? You need to identify. That is the purpose of the database, right? You should be able to very quickly, uniquely identify each lecturer without having any problem. So that is what we mean by the identifier, right? Identifier. So when you construct the entities or the objects, once we determine the attributes, we need to determine what is the identifier, which one I need to use as a key to identify a specific instance in that object, right? So we give a kind of a special name for the identifier in the database. We call it as a primary key. We'll come to that later on, okay? Primary key. identifier or the primary key, right? So what we do is we identify that identifier and we underline it. So here subject, the primary key or the identifier is the subject code, and in the lecturer, the identifier is the lecturer ID. So that means if I know the subject code, I know exactly which subject I am talking about. If I know the lecturer ID, I know exactly which lecturer I am talking about. Right. So there are certain rules associated with the identifiers as well. Now remember, identifiers has to be a unique, right? So each entity must have an identifier, but if you have an identifier, that identifier has to be unique. You can't have any duplicate values. If you have different same subject codes, that is not an identifier, right? So when you choose an identifier, you need to choose a something or some attributes that uniquely identify each record without having any trouble. Okay. So in this case, I selected the subject code because we don't have any duplicates, right, for the subject code. Again, in this case, I selected the lecture ID because we don't have, each lecturer have different employee IDs, right, which I call it as a lecture IDs, right? So it's a unique number. There's no duplicate, right? So the other important thing that you need to know, I will come to this a little bit later on, is if you have identifier or the primary key, that identifier may not be empty, or we usually call, we have a technical word for that, we call it null. We can't have any null values or the empty values in identity in primary keys. Okay? So if you see the null means we don't know the value, right? Null means in the database we don't know the value of that particular case. Okay? So the primary keys, you can't have any null values. Okay, so these are the things you need. So these are the important three attributes or three things you need to know when you're choosing an appropriate primary key or the identifier. Okay. All right. So what next? Right now, what we need to do is we need to translate our model. Now, once we build the model, we need to translate into the relational scheme. We call the relational schema, right? Now, the first step is we identify the objects. The second step is we identify the attributes. Third step is we identify the relationships between the entities. And then we identify the identifiers of each objects, and then we need to actually identify then cardinalities and the cardinality constraints. Okay, and then of course we can translate that model into so-called the relational schema. Okay, so relational schema is something that we describe our model that we build in a kind of English language, like kind of sentences like this, right? This is the step before we convert into the machine readable form. Before we write the codes, or we write the SQL codes in databases, so yeah, the machine can understand, or database management can understand. So this is the preliminary step before we move into that direction. So we call the relational schema. So this is how we write the relational schema. For example, if you think about the lecturer, the relational schema looks like this. We write the name of the entity, lecturers. Usually we write it in the capital letters. And then within the brackets, we write all the attributes, right? So 3 attributes in this case. And then we underline the primary key, right? So this is the example. So this relational model actually introduced in 1970s called EF Cole. Now he's the godfather of modern databases. Right now, explain. See how how these days, 1970s, they invented this so-called relational model. How old this technology is, isn't it? So what the code says, yes, we can represent all these information in two-dimensional tables, right? Which is we call it as relation or the entity. So he invented this model, right? So every information we can be recorded in the system in a rows and columns, right? Like a Excel spreadsheet. Think about Excel spreadsheet. We have columns, we have rows, right? So what he says is all the pieces of information that we try to build in the database, we can organize in a rows and columns, right? So what he says is order of the rows are not relevant, because as long as we have the primary key, order is not relevant because we can pinpoint exactly the record we are looking at by going through the primary key, right? That is what he has mentioned. And one of the important thing is when you're building the relational model or the tables or the relation, we can have only one single value for each cell, right? Think about Excel spreadsheet. We can't have multiple values in a cell, right? Single value for that is what we mean by this sentence, right? So we have rows, right? So we have rows and we have columns. So in a table in databases, columns called the attributes, rows we call the instances or the records. Okay, that is how we organize the data. So this is an example. This is how our lecturer table organized in a database, right? So we have columns, attributes, and the rows, data values, right? Rows contains the data values. So here I underline the primary key, right? All right. So this is how we convert into the relational schema. Lecturer will become the lecturer relation. So I have written it in the English word and then underline the primary key in this case. So remember the uppercase, right? We write in the uppercase. Usually we write the column names or the attribute names in the lowercase. Your capitalized lowercase, I would say. So it give a kind of, so if you follow these instructions, it will be easy because these are the standard we are using in the industry. So it's much better you guys learn these standards. Right. So the nulls, this is how we show the null. Now, null means, as I mentioned before, null means if you don't know the value in a particular cell, that is called the null. So null doesn't mean there is no value. Null doesn't mean there's something that missing. It means that we don't know the value yet. So this is what we mean by the null. Okay. So if you think about this question, this small table, so we have two lecturers, John Smith and Karen Fry, and one John has given his age, right? But Karen says no, I don't want to give age, so I will keep it as a null in our database or our table. So if I ask a question, is the Karen is younger than John? We can't say yes or no, isn't it? We can't say yes because we don't know the answer because he hasn't specified the number, right? So null means not zero, it's not a space. So null means we don't know the value of value.